fixed, like how long it takes for them to grow to the adult size. So an individual in time has a sort of a lifespan, right? And so maybe these have a clear lifespan, and that might help to individuate them. So maybe in that way, Huxley's idea of the individual in time, is that what it means?
Yeah. And the part says that eventually heterogeneity of the heterogeneous part that is succeeding time. Eventually.
Yes.
I'll make a final question then. We have Stuart Newman here with us like 3 months ago, in November, no, not 4 months ago.
Yeah.
And one of the papers he gave us to gave the students to read was the experimental evolution mode cellularity.
Okay.
And but Stuart argues that the evolution mode cellularity, at least in animals, have to do with the increase of calcium in the Precambrian seas, which made the cells stick together, and they couldn't avoid it, so have a new selective regime and molecules that were acting in the cellular organism in one way begin to work differently. And here you have, if we accept this multicellular organism, evolution of multicellular by natural selection and artificial selection. Do you think these results can?
I think according to like the contemporary literature, multicellularity is thought to have evolved at least 25 times, right? 25 different, and we're not making the claim that this is how multicellularity evolved. We're making the claim that this is, or we're saying what's significant about the result is that this provides a plausible mechanism. The big surprise for us was how fast this can happen, right? And so maybe you can get the evolution of multicellularity quickly, so maybe it happened a lot more than 25 times, and then it wasn't advantageous for whatever reason, and it went extinct. And then, at some point it came back, and then it took off. So Newman's idea, high levels of calcium in the ocean and aggregation, sure. I think that's another possible account. I think what's nice about this system is we can now, as I was saying before, continue to run these experiments on the system and ask these kinds of questions. If you make the plausible hypothesis that under highly calcified seas, I mean, maybe they need to find a contemporary marine microorganism, stick it in some, highly calcified seawater and see what happens. Maybe they'll get multicellular organisms. It might be super easy. I mean, Travisano, Mike has said many times that people working with yeast probably had this phenotype. Brewers, when you're making beer, when this happens, when the yeast stick together, it's a problem. So you throw it out. So Mike was like, there's probably many people who work with yeast who had this phenotype and just pitched it. Because that's not what they were looking for, that wasn't their experimental setup, that's not what it was designed to investigate. This one started with the idea like, oh, well, let's see if we can get it. And then when we got it, for us that meant something. But for other people, it really didn't.
This is a good example of serendipity.
Yeah.
So I'd like to thank Mark again.
Thanks.
And to thank all of you for the patience. Agradecer a todos vocês pela paciência e agradecer a todos os convidados de modo geral.